Biotechnology is widely used in primary production and harvesting because once changes are made here, they can be permanently used without ongoing costs. So the setup costs might be more, but ongoing costs are good. One of the problems that's occurred in agriculture is the increased use of nitrogen means that plants are thinner and weaker, so they fall over, making it very difficult to harvest and causing yield losses. Farmers are using or developing semi-dwarf varieties of many cereal crops because they're more resistant to wind and rain damage. So how do we know that this is actually a real issue? We can compare semi-dwarf varieties of wheat, and if you look at the yields of these plants, they're around 10 grams per hectare, whereas if you have the taller varieties, there's 4 tonnes per hectare. This means that the semi-dwarf varieties are giving at least more than a 2-fold increase in yield. So having better plant varieties, we can double the yield of wheat. Not surprisingly, the rice breeders are very interested in seeing if they can do that for rice. When people have looked at naturally occurring mutants, they've found that many of these have reduced levels and or perception of gibberellic acid. So if gibberellic acid is not present or perceived, then the plants will be smaller. This then creates an opportunity. Knowing this information, knowing this information allows. So one possibility would be just to take these existing mutants and use those to have your semi-dwarf varieties. However, many of the naturally occurring mutants don't have the other agronomic traits that make the varieties high yielding or other characteristics that consumers want. So genetic modification is being widely used to target elite varieties of plants and to tailor-make specific changes in a directed way. So we're going to look here at examples of making semi-dwarf varieties of rice by modifying the gibberellic acid pathway. So this is where biochemistry comes in. We need to know how gibberellic acid is made. There would be 2 ways of... so this exercise is going to get you to do some prediction about how you might go about doing this. But in simple terms, we can either inhibit gibberellic acid being made or degrade more gibberellic acid. So let's go look at that pathway. Aren't they awful? So you will be pleased to know you don't actually need to know the details of this pathway, except that it's complicated. There's many steps. The active gibberellic acid, known as GA1, is synthesised in about 5 or 6 different steps there. This active gibberellic acid can be degraded by an enzyme known as GA2 oxidase. So this degrades active GA1. So one approach is to make more of this enzyme available, and that should then, so what would happen then? That's for you to do some predictions on.